And we're back for some more Bangalang. So welcome to another coding session. We're going to continue with our feature list. If you've been following along, you might have thought that this was coming next, but then I snuck this one to the top of the list because I think it's a cool feature to have. I would like it. So, but before we get into anonymous procs, I do have to address the fact that I was a bit hasty last session with our swizzling, and we never tried. Where is the swizzling? We never tried swizzling a slice, which is quite a different use case. So I'm going to make a second test for a slice. We're going to say var1 is just a slice of var0, and we're going to make these 2, 3, and 4. So 2, 3, and 4 are what we test. So it should be exactly the same as the test above, except now we're performing, well, we need to do var1 here. Now we're doing the swizzling on a slice. That's it. So let's see what happens. I have a feeling it's going to break. Okay. Oh yeah, sometimes that error that I got just before is, sometimes ever since I started trying to grab the first argument, like os.args, it sometimes fails. I don't know what the deal is with that. Anyway, we've got this more pertinent failure here. Index out of bounds with swizzle slice. So this is compile time bounds checking, which should only be for arrays, because at compile time we don't know how long this slice is, so we can't say that we're out of bounds at compile time. So that seems like an error. Where was this stuff? Was it? No, it was in identifier. So where do we have this? Here we go, swizzle member. So that's what I thought this was for, but I'm just realizing now that I'm checking if index is not equal -1, and it's never going to equal negative. Well, if it does equal -1, we quit out here, right? What I actually need to check for is length, because length will be -1 if it's not an array, i.e. if it's a slice. So by putting this condition here, I'm saying, like, don't do this bounds checking, if we're dealing with a slice. So that fixes that and gives us another error. Great. At 73, we're double dereferencing. So let's have a look at the generation of an identifier. So this is it, right? We're taking this address location and then we're dereferencing it. This memory will put square brackets around it basically. But I guess this already has square brackets. It's already, where was it? This. So maybe if we just put that into a register, and then whatever register that is, say R11, can be here. And then it only needs a single set of square brackets. And I guess for the other case with the array, it was already a register, so it didn't matter. And this will be a no op, because it's already in a register. So context, the address location, we want to put it in this register number if it's not already. And then we need to give it a type node, I think, which should be this reference type node, which I do want to change the name of. I think this unknown part is not necessary. It's just a reference type node. It's just a node that's type reference. That's it. Let's see if that works. Well, I'm not seeing any errors come up. Cool, it works. But now, because as we saw before, we're not doing bounds checking for slices, we need to add that. So we should do it before here, because we might not even, even one might be too much. So we need to go through and get the max index, I guess. Let's just put it here for now. I'm not sure exactly where the best place is for it. So if we say max index is 0 and then for chart in node.value, we say, it's kind of like basically this, right? We get the index, and I guess we say if index is greater than max index, do max index equals index. I think I showed you guys this in the last video, right? Yeah, it looks like I've used it in a few places. I like this do. We're going to elaborate on that in this video. So this loop here should get us the max index that we're accessing of the source array. So then we should be able to say, we should be able to do format dot sb printf line, and we will do like a compare. A compare of what? Well, we need to compare this max index, which will have to go on the right-hand side because we're going to use an immediate. We say to operand of immediate max index, which is basically just going to put the number here, the max index number. And we need to compare that to the length location, which we can get here. Ooh, don't know what that was about. Let's put this here. Okay, so we're comparing the length to the max index. And there's like this panic out of bounds, something like this. We want to jump to panic out of bounds if we're out of bounds. So what would be out of bounds? So comparing these two, I'm just trying to think which one is which. If we go if we go to the place where we do this, what? That's not very helpful. There. Okay, so here we're comparing the start to the length. And we're saying that the start expression, if the value in this, so this is the index basically. So this is very similar. We're saying that if the index is greater than or equal to the length, then we're in trouble. That makes sense. So we're saying the left is greater than or equal to the right. So here I guess would be less than or equal. If the length is less than the maximum index we're using or equal, then we're out of bounds. So if we go back to our test, if we have 4 here, so if I just change this to 3, we should get an error here and here. Well, we should get an out of bounds error. Ooh. Size not specified. Line 70. This is our comparison, our bounds check. So I guess it's memory intermediate, so it doesn't know what size it is. That's fair. So we'll give it a size. We know it's going to be qword. The length is a 64-bit integer, and qword is saying 64-bit sizing. And assembly. We still have an issue. Oh, it does not like that. Well, here it's got two. Okay. So what I should have done is said, we only want to do this for slice, right? Just lucky that threw an error. Otherwise, we'd be doing unnecessary bounds checking. Okay. Now it says index out of bounds. Cool. If we look at the assembly, where's our bounds check? Oops, I feel like we jumped there. Oh, swizzle slice. Oh yeah, because it continued and did the other tests. Okay. So we don't actually get to see the assembly, but I'm pretty sure that it's right. Because if we correct it, so now there shouldn't be anything out of bounds. Now everything should pass fine. And that'll be our swizzling. I'll be happy with the swizzling if that passes. Okay, that'll pass. Cool. All right. Now, let's actually get onto something new. And that new thing I want to get onto is anonymous procedures. And what do I mean by that? Well, okay, so another thing I want to try actually is I want to have different files. I'm tired of, because at the moment I've been like just commenting everything out in this file and then putting a little example in. So why don't we just create a new file? Playground.bang. And we'll rename this one to opengl.bang. And in our main, that name will be os.args1. And here I'm going to do a format.a printf bin/name. Yeah, I'm starting to enjoy this more than, like, say this. I feel like this is more concise. In fact, let's do, oh no, that would be $.bang. Yeah, you know, I just feel like that's a bit nicer. Yeah, maybe I'll start using that in more places. So now it's going to take, finally, I feel like we've gone way too long to get around to this. We're going to take an argument to the program. So examples.playground. So I'm going to say this is bang examples playground. Apply, and then let's copy that and say examples OpenGL. So this will run OpenGL. And then another one I want to do is bang -- tests, and have that as the argument. And then here I'm going to say if, let's put this name up here, and we'll say if name equals -- tests. Then we do the tests, and we'll just, oops, I've deleted that. And then we'll just exit at the end after all the tests, and If failed test is greater than 0, then we exit with code 0, otherwise code 1. Code 0. Code 1. If we have failed tests, we exit with code 1, otherwise code 0. What's wrong with this? Oh, we need a length of failed tests. Okay. So then in theory, if I do this, it should just run the tests, which I think takes about 10 seconds, and then it should exit with, hopefully with code 0. There we go. This one should run the triangles. But it does not. I think it might be because, I've introduced this folder now. Like this name is example/playground or example/OpenGL, and probably in bin it needs to create that directory. I'll probably need to fix that up, so that it actually does that. There we go. Okay. And playground, if we run that, it'll probably just exit. There's nothing to do. But now we have this playground that we can work in. So we can finally get to actually showing what I mean by anonymous procedures. So if we have foo, which is a struct, and it has a member called bar, which is a procedure, this might look a bit weird. It might look like I'm defining a struct here, but I'm actually defining a variable foo of type struct. We could do like foo_t equals, and this is creating a type alias. So then we could do like that. Now we're declaring a variable with that type. So this, but this is just if you don't need to reuse this type, you can just put the type directly here. You can do either. So I'm just going to do this for now. And then we can say foo.bar equals like strings.println foobar. And then we should be able to do foo.bar. And we're going to have to import strings from the core library. Okay, that should throw an error right now. It throws an error actually that I do not like. And I am aware of this. I've made a note of it. So I'll fix it at some point. Because if we have a procedure here on the right-hand side that doesn't return anything, then we should not be able to assign it to something. Doesn't make sense. But the idea here is that I want bar to be a procedure with a single statement, and this is the statement. And this is where do comes in, because to make things more clear, I could go like this. So now it's a scope with this statement. But when there's just one statement, I don't want to have to do this. And instead, I want to have do. I've already played with this. You can see it's highlighted. So the idea in my language, I'm kind of stealing this from Odin, but I'm doing it a little bit differently, is that do represents a scope. Do and then one statement is a scope with one statement. That's basically what it is. So anywhere where there's a scope, anywhere where a scope is needed, so it could be in an if, a for, a switch, a procedure. You could either have curly braces around multiple statements, or you could have a do with a single statement. So actually, let's go to the grammar and implement that. So I'm going to say a scope statement. At the moment, see it's multiple statements surrounded by curly brackets. I'm going to say it could be a single statement preceded by the keyword do. There, so a scope could be do statement, or it could be multiple statements in curly brackets. Cool. So how would we parse that? Well, first we need in our tokens, we need a new keyword. Haven't added a keyword for a while. So we'll make the keyword do. And then when we're parsing, I should also, yeah, I'm going to take this opportunity to say, like, because there's quite a few places where, like if statements, for statements, where it was kind of, you didn't really need to use a scope, it was optional. So let's look at everywhere where a raw statement is happening. Let's see what we want to do. So for like, yeah, for like if I want to say it's a scope statement, there's three places. There's if, there's else if, and there's else. I want all of those to have a scope. This is, I think, the for loop and switch. I also want the bodies of those to be scope statements. And then the other places that raw statements are used is in assignment statements, these three variations of an assignment. And I want to restrict that a bit more too. I want that to be either a scope statement or a right-hand side expression. I think I need in this case to put it in brackets to be clear about what the OR is, the scope of this OR. So a scope statement or right-hand side expression. Goes there. I think I remember there was somewhere where it's a bit funky. Here it is. That's not needed. So let's see if that came out all right. So we can see in lots of places we need scope statements now. And here we need a scope statement or right-hand side expression, as well as here and here. Cool. So let's update our parsing for that. I guess the first thing is we should do the scope. So if we peek and we find a keyword, and that keyword is do, then we have a do style scope. In that case, we want to consume that keyword do, and then parse a statement. And that's it. Otherwise, oops, we want to do what we did before. This is a bit funny, actually. I feel like the way I normally do this kind of thing is I just say, as long as we haven't found a closing curly bracket, then keep parsing statements. And then at the end, we consume the closing bracket. Like that. And if we get to the end of the file before there's a closing curly bracket, then we'll get an error from this. So it's covered. I feel like that's much cleaner, actually. So we either have do in a single statement, or we have multiple statements surrounded in curly brackets. I like this parsing code, you know. I like the parsing code we have. It's very clear. So that's a scope. Now we need to do like the for, the if, the switch. Should I do this while we're here? Yeah. I'm going back and forth on this, but I think I want to get rid of these optional brackets that we have for for and if. So there's optional bracket. Especially now that we have do, I feel like that was kind of where I had the problem. Like there was a bit of, I felt like stuff that was not so clear, but now I feel like it's not an issue. So, okay, nice, we've got rid of those. Which means that in here we can get rid of all this back bracket handling. I don't care about brackets. Oh, looks like the else we couldn't do brackets before. Okay. So I think we should call this the if expression node, because we have else if and else. But this should be a scope. It's an expression and then a scope now. You can't just put any old statement in there, it's got to be a scope. And here as well. Cool. So that's if, requires scopes. For, let's get rid of these brackets. So this is the body of the for, so this is our scope node now. That's easy. And then switch was the other one, I remember. Yeah, so for each case we have default node, token is default, then consumer default, then consume the default node. We just create a default node. I'm a little bit confused about that. Oh, otherwise we do an expression. Okay, and here's the scope. Okay, I got it now. Okay, I think that's the switch sorted. Was there something else? Our assignment statements we need to update. So assignment, the right-hand side is now, okay, so this could be a scope or a right-hand side expression. So I think we can take this and say scope or RHS expression. Just cut that out. Assignment we don't need, so we've got scope and RHS expression, the two options. So I think we just cut this out like that. So we try to parse both of them, we see which one we got further during parsing, and we use that one. That's basically what that says. So here we would want to parse a scope or right-hand side expression. Cool, and then there should be declaration. We'll do the same thing, and simple assignment, that's what it was. We'll do the same thing. Cool, okay, I think we've matched our grammar now. So type checking. One thing that we have in type checking, is it in here? Yeah, this wrap and scope. This was to make up for the fact that we didn't always have scopes for like ifs and fors and things. But now we do. So yeah, so we don't need to worry about that. We can get rid of it. This is in the for loop, so we just get rid of that. This is in the if, so wrap and scope, wrap and scope, wrap and scope. This is a procedure. This is the switch. We get rid of it. So for procedures, I'm also going to get rid of this. We haven't enforced it for procedures yet, but we'll get to that. And we'll get rid of wrap and scope. Cool. That's simpler. I like it. I like to cut out code. So I don't think we need to actually change anything else about type checking for all of these statements. You know, if, for, switch. Well, assignment we do. Assignment we do. And procedure, what did we... That's right, we cut that out already. Probably going to need to make some changes in here. So another thing here is that we wrapped in return. So because previously you could have, if I had proc that returns an I64, like that, I could have foobar equals 5. And that would implicitly, it would convert it to this, implicitly. So it would become a procedure that returns 5. And that, when I was looking into anonymous procedures, that kind of unwrapping, that was where things got tricky, because I would also be able to want to do like Baz is that a procedure that does that, and let's say, so that's a procedure with the same signature as this one, then I should be able to do this. That's another thing that we should be able to do. And it just gets all very complicated if you can also just do this, which becomes a procedure body. So if I have force that you have to do this, then it becomes a much clearer. Let's go back to where we were. I want the print code actually. There we go. So long story short, this is not needed anymore. We don't need to, this was wrapping it into a return, but because we explicitly have to say return now, we don't need that. So this is getting smaller, which is nice. Now type checking assignment, I think this is where we're going to have to do a bunch of work. I think we need to do it kind of up front. So I'm using the terminology definition because declaration for me means you're declaring a new variable. And I want this to catch this kind of scenario where we're not declaring a new variable. We're just assigning to a member of an existing variable, but we are declaring a new procedure. This is our anonymous procedure. I didn't really say that before, hey, but this is our anonymous procedure because it doesn't have its own name. Like before when we went to like this, you know, this is a procedure that has its own name. Its name is Baz. But this does not actually have its own name. It's anonymous. So I want to know if this is a procedure definition or not. So if our left hand, we've type checked the left hand side, which means that the left hand side must have a type now. So I think we can lift this up to here. Well, I kind of don't want to do that because we do have this thing further down where we get, this is where we get it. And it's important that we're getting it at this point after, like this could have happened, which sets it. Gets a bit complicated, but I think we're just going to use this again. So if we're looking at a procedure, I feel like there's some other conditions there too. And I can't remember what it would be, but we need to get more specific, right? If the left-hand side is a procedure, we'll just go with that for now, but I feel like we need to do more. Then we want to do some specific procedure stuff. And I also want to look in here and see what is, oh, also, That's right. This is where I was thinking to. Yeah, okay. Yeah, that's another restriction. So like before, I was saying you could have some variable assignment here. So this is not a procedure definition, but this is. So it needs to be a scope on the right-hand side. So this is where we restrict it so that procedure definitions need to be scopes. So I think we can either say that there is no right-hand side, or if there is a right-hand side, then it should be a scope. Okay, it needs to be a scope. All right. Yeah, so down here, further down here, there's this part that I added. So if it's a scope, convert it to a compound literal. Let's make that a do. So this obviously does not apply if it's a procedure definition. We should not do that. So let's say if it's not a procedure definition, we'll do this stuff. There's also a few other things in here, like right-hand side must be an expression. That's obviously for non-procedures. Type checking the right-hand side, that's also for non-procedures, because for procedures that will get this, that will happen at a later date or a later time. We'll get to that. This is if the left-hand side type was not known, then we assign it from the right-hand side. But in the case of a procedure definition, we've established that we do know the type of the left-hand side, so that's not relevant either. So I think all of this stuff we can put in here. This stuff here is making sure that the assignment is the correct type, so we only allow equals here. So this should, oh, I think we need to just maybe put this here as well. So this will take care of that, that's fine. What if right-hand side node doesn't exist? Oh, it does, okay. This here, again, that's not relevant for procedures, but it doesn't hurt either, so I'm just going to leave it. And this here is where we add, we check about allocators, and we add to the identifiers. We're going to have to look at that a bit more closely later, because procedures are a bit special. If they get added to the identifiers earlier, but let's leave this for now. I think this is kind of our assignment. Oh, we actually need to do something in here. And for that, I wanted to have a look at statements. So this type check statements is for for any scope, basically, we call type check statements, which goes through all the statements and type checks them, basically. But you can see that's like this part here, where it goes through all the statements and type checks them. But there's all this stuff that happens first. And this is like the pre-loop. I don't know what to call it. It's like pre-processing. Yeah, it's like the preprocessor, you could say. So it loops through the statements and resolves types. This is more type stuff. It also does this. It handles link statements, which is, I feel like we could move this out of here. It doesn't really need to be here. Handles imports. I mean, the idea of this is that it makes sure all of the types are correct. And really, the only reason that all of this has to happen is because it also, for any procedures that it finds, adds them to the identifiers and does some other stuff. And the reason it has to do this before this main loop is because you can call a procedure or reference a procedure, a static procedure, before it is defined. And in order to put them correctly into this identifiers list, we have to make sure all the types are correct up until this point, which is why we do all the importing and type resolution and stuff like that. Anyway, that's what's going on in this loop. This here is kind of like saying, okay, we've found a procedure. We want to add it into the program and also add it to a queue. And this queue is basically all the procedures that we want to type check. And I think this is the part that I want to take out of here. I don't think we need that. And put in here. And then this loop here, which normally would ignore these, because previously they were taken care of up here. Now we're going to take that condition off. Let's have another do, shall we? And so they're going to get type checked in the main with everything else. It's just important that they're in the identifiers first, but the actual type checking of them can happen here with everything else. That's fine. Looks like we need to import program. Okay, and statement is actually node. Okay, so this is handling that. So then my hope is that at this point, we've changed things around a bit, but things should still work. Like if we go to the OpenGL program, we see comp exchange has already been declared. Interesting. So it's in globals. It could be because like we've put it in the identifiers here, and then we go through and type check all the statements, and we come across, I'll open up the globals. We come across these lines where they declare procedures, but because they're already in the identifiers, and then when we type check those declarations and we check the left-hand side, it says, hey, if this is a declaration and the identifier is already in the identifier list, well, that's it's already been declared. That's an error. So that's a bit of a weird thing about these getting predefined, and it's a bit annoying because it also has been an issue because previously I'd kind of worked my way around that, but then it meant that you could redeclare the same procedure multiple times with the same name. And I think what I want to do is add an out of order identifiers, so a separate list to the context. Like that. And then when we're looking for an identifier, we also look in the out of order identifiers. But I want to make that conditional. Include out of order identifiers. Oh no, it's like skip out of order identifiers. And if we're not skipping, then we look. Yeah. So by default we don't skip. By default we do look in here, but we can override that. And that's what I want to have happen in here, where it's already been declared. I want to say, don't look at the out of order ones, because that's going to give us false negatives. So hopefully that will do the trick. Now we have invalid token, curly bracket, expected curly bracket, but got plus equals. It could be because, you know, we changed a bit of syntax. I wouldn't be surprised. So if we go examples, OpenGL 68. Yeah, so this needs to be do. This is a procedure body, so it needs to be a scope. So it needs to have a do for that single statement. That loop will also need to do if it's uncommented. I don't think we have much in here. I think that's it. But there's going to be a lot of places probably that come up with these errors. I want to improve parsing errors because I do want parsing to do a lot of heavy lifting, but right now this is kind of like not actually that helpful. I want them to be more contextual. Threading. So this needs to be do because this is a procedure body. This is the body of the for loop. Same with that and that. Here, if do return. What else we got here? For loop with do. Do. I think that's it for threading. Linux. So it says like these are not declared because I guess it's kind of, it's trying to just parse this as a right-hand side expression. And then it's saying like, look, I don't know what this is, this variable, because you haven't declared it. But I think that's will get fixed by using do. Okay. Core strings. We don't need that open. So core strings 18. Do break. Print, there should be a do. We can make this a do. I actually want to change this at some point. It's like a backwards loop, but I think we could do it forwards. And the benefit of doing it forwards is that then we can go, then when we find a like a character that's not an integer, or not a digit, then we can just say this is the end of the number, which we can't do right now. Right now, the whole string needs to be a number. Anyway, that's an aside. Size has not been declared in memory. Probably here. Code has not been declared in CoreOS. What else we got here? Examples util. Line 20. If do. Must provide a procedure body when using allocator stack. Boomstick 31. Okay, that's a bit different. Boomstick 31. It's probably because this here is declaring a procedure, but because it's a parameter, I force it to be stack allocated. Now, in general, if we declare a procedure that is stack allocated, we don't want a procedure body. Because stack or heap or VRAM, well, VRAM doesn't really make sense, but any kind of memory allocator we use, that's implying that we're just going to have a pointer to a procedure, not defining a procedure. So we might have to make a special, maybe our procedure definition. We need to say and if we get the allocator and we say it's kind of hard to say not, maybe for now I'm just going to say allocator equals GLSL or allocator equals static. I think those are the only two that are actually definitions. But is that going to mean that, like, I wonder if on this line, because the left-hand side is not static on this line, so that might cause an issue. Segmentation fault. So we're trying to generate procedures. Qualified name is glfw init. But I guess the procedure is null, it doesn't exist. So does that mean it didn't go in here, I guess? I guess it didn't think it was a procedure definition. Because then that should have put it here. Wait, context of, yeah, I think this is still correct, even though I copy and pasted it. I think that's still correct. So I wonder why that didn't go in there. It should have had allocator static. Oh, wait a minute. Oh, it's got allocator none. Or extern. Allocator external. So there are a lot of other allocators that actually should be procedure definitions. So maybe we will go with not equals heap or VRAM. No, but that's causing that problem from before, right? So I guess it either should not be like a memory allocator, or if it is a memory allocator, it needs to be a member. So it's like, I think I have like an is member. So either we're talking about a member, this is getting really complicated. Either we're talking about a member. So if we're talking about a member, then it's always good. Or it can't. No, but then for the parameters, that still doesn't work. What is the correct condition here? Did I never start my timer? I don't think I did. Let me just check. We're nearly at an hour. So I hope I can nail this. I feel like we're getting close. But it's just this condition that's really tripping me up right now. So procedure definition, if it's a procedure, either it's just a left-hand side, or we've got a scope on the right-hand side. And why are we restricting it by, I can't remember now why we're even thinking about restricting it by allocator. Can we go back to this and see where the error was? Must provide a procedure body. So maybe this is actually what we should change. Must provide a procedure body when using allocator. So we only want to, okay, this is where I think it makes more sense. If GLSL and static are the only two allocators where you should use a procedure body, right? And then down here we have the opposite, so I guess that should be where allocator does not equal GLSL and allocator does not equal static, then you shouldn't have provided a procedure body. I think that's not going to work though. Well, it worked for this part, but I think for the anonymous part it's not going to work. I think this condition probably should be more lenient. Yeah, I'm going to leave that where it was, because for anonymous procedures you'll be assigning to any kind of allocated variable. So I think this is right. Okay, so OpenGL worked. We'll get to the tests later. Our playground should fail. We get an error because we haven't handled anonymous yet. So in here, when we get a procedure definition, the way that we know, how do we know that it's anonymous? I think we can use an AST here. We have like is static procedure. See, so if it's a static procedure, it can't be a member of something, and it has to have these allocators. So I think we can say if it's not, I'm not sure where to put it in here, but we'll put it at the bottom for now. So if it's not a static procedure, we need to make up a name. So right at the moment we use the left-hand side as the name, but we can't do that for anonymous procedures. We just have to make up a name. So let's go like name equals that. Yeah, because I think this would all be the same, just with like a different name. So maybe we'll put this like up here. So if not static, name equals, let's use our good old printf. I'm going to do something weird like anon underscore, and then we'll put like an index. I don't think this context actually has a next index, so we're going to have to add one. Yeah, let's just add a next index. What is the generation one, out of curiosity? What was that again? Label index. Maybe I'll make that also just next index. Okay, so we've made up a name for our procedure now. And the other funky thing I want to do is basically change this assignment statement. Ooh. Change this assignment statement so that the right-hand side, instead of being the procedure definition, like, you know, in our procedures list, we're going to save the original statements, you know, but I want to make a copy of this statement and say that the right-hand side is a static variable with this name. So then in the assembly, it should work out to the correct assembly. Let's try that. So I'm just going to call it like new node. So it's a new assignment statement. I'm going to do it like this because I'm worried about, because when we do copies of nodes, they're just shallow copies and the children get moved around with them, and yeah. So I just want to make a whole new node here, and the left-hand side, I think we can just take the left-hand side as it is. The operator can be we need to take out that equals. There's an assignment, so it's just the equals. And then the right-hand side node is where we're going to have our static variable. So it's an identifier, and the name is the name of this procedure. And I'm going to say allocator is static, so it gets treated like a static variable. And do we need to give it a type? We probably will. We'll leave it for now, but I have a feeling we need to give it a type. And then I'm going to say node is new node. But I think we need to move, because we want to put, when we're recording our procedures, we want to record that original statement that has the procedure body, obviously. So let's do that up here. And let's see what happens. Error. Oh, when I renamed label index, it looks like it didn't really work. I spotted this. What is this? This is like the... Because normally I give them more of a name than just index. It's like slice index. It's like, I know this is like the array behind the slice, so slice array index. I don't know if that makes more sense, but anyway. Okay, let's try that again. Get an error. I should have known. Contains allocations. No, we don't need to change that, but why is that an issue? Probably because it's trying to get the type of something, and I haven't given, remember just before I said we should have provided a type. So this is a non, it has no children. And here it's assuming that it has a child. The first child is not a type. Yeah, so the first child should be a type. And I'm wondering if we can just put a none type node here. I mean, I guess we could just take the left-hand side type node and put it in. Yeah, why not? We'll do that. So this is child 2. It's the third child. So child 2, we're going to add a child to it, which is, well, it's the left-hand side type node. This. So that gives us some type information. Hopefully it's more happy now. Struggling to get a qualified name. What is the node value? Anon. Because it wants to get an identifier path. But we never added it to the identifiers, I don't think. So I guess that's another thing we need to do, is say that this is a thing, and what node would we give it? I guess we'd do this down here maybe and give it this node. So this node here, just the identifier with the type. I guess that's the closest thing to a correct node. I don't know if it's actually going to get used much, but okay. I feel like we're making progress now. We got to the assembly. I'm going to close a few of these things. So we got to the assembly and we found that there's no definition, and I just closed a bunch of stuff, and then I realized probably in type checking assignment we can resolve this, because it's not going to generate our procedure if it's never referenced. That's something that I've got in my compiler. So, and I think it's like generation of identifier where we create the references. Is it not identifier? Oh, no, sorry, it's type checking still. Type checking of an identifier. Here we go, reference. This is creating a reference. So I think I'm just going to make like a utility procedure for this. It's not so much work, but maybe nice to have it extracted. So we need to pass the context in, type checking context, and what else? It looks like a path and a name. Name, path. It looks like we have two things with the same name now. So we're creating a reference. So the reason I did that is because we can go back here and we can say, okay, we're creating a reference with this path and this name. Boom. And there's another place up here where we do it. This looks like it, but now we use this path. Looks like we need to slice it, and still that name. Like so, and then over here, we want to reference with the context path and the name. So now that should create a reference to this anonymous procedure, because it's never going to get referenced anywhere else. Still not defined. Okay, I'm a little bit surprised by that. We do come in here, right? We do come in here. We step in. So we get the procedure, which is that. And then the path, so the path should be, the path in our case is the context path, so it's the same as this. I don't think we need to. Do we need to slice that? It's already a slice, isn't it? Yeah. With the name on the end, that becomes the final path. So we're creating a reference to it. Is there some reason in generation, when we generate procedures, that it would not get generated? The allocator is going to be static. No, it's going to be stack, because if we look at our source code, the allocator of this is static. See what's allocated just here is a static variable. So I'm just wondering if it doesn't have an explicit allocator, maybe we should just make this the default. Foobar. It worked. We printed out foobar. I want to run OpenGL because it's like a complex example. Yeah, to see that nothing broke, but something broke. So what's our left-hand side? Func. So this is... So this is a procedure argument that it's trying to generate. It's a procedure argument. So because when we type check a procedure, we go through, is it here? We go through all the parameters and we type check them like assignments, which takes us into here. And then we see like, hey, oh, we can take that out. We see like, hey, this is a procedure definition. So let's do all this stuff. But we don't want to do that. Maybe if there's only a left-hand side, for it to be a definition, maybe we need to say like, this is a static procedure, or if it's not a static procedure, it needs to be a procedure, obviously, but length needs to be greater than 1, which means there needs to be a right-hand side. And that right-hand side needs to be a scope. Maybe that's a better way of saying it. So either we've got a static procedure definition, which is like what we were covering previously, and this new thing that we're handling for anonymous procedures is it's a procedure with a right-hand side, and that right-hand side is a scope. Because parameters don't have right-hand sides, which are scopes. Well, I guess they could actually. They could, and if they did, it would be valid for them to get generated. Okay. So that worked. I'm curious to have a bit of a look here at our playground assembly. I don't like how this is here. It doesn't need to be there. Okay, so here we go. We create something which is 8 bytes, which is this, because all it is it's a struct containing a procedure pointer. It's containing a pointer, so it's 8 bytes. Then we assign to that pointer this procedure. And down here, this looks pointless to me, but we copy the thing at the top of the stack to R11, and then we call the thing at the top of the stack, which has been assigned this. And this is our procedure, which just calls printline with a string. Yeah, looks good to me. Looks good to me. OpenGL worked. So let's try the tests. I'm expecting them to fail stupendously because we have a lot of tests that will now need do. I played with the syntax quite a bit, so let's see. Yeah, a lot of these ifs and fors that don't have scopes now need to have a do scope. I thought I heard my fans whirring up. Let's cut that out. Come on. You don't want to die. If else, these ones have scopes. If else, if else, if else, if else. Oh, else if true, do. I thought I was going to get these in some of the wrong places. Else if true, do. Okay, I guess we'll find out if I put do in some wrong places. If false to, else is false to, else do. This has brackets, which is not allowed anymore. So I guess that's not really part of the name. Non-scope. I guess that would be do scope now. Okay, these look good. Maybe just run these and see what happens. I'm sure there's more errors. For break, do break. I think there's another one that's for continues. Yeah, for continue, do continue. I would like this window to die, but I don't know how. Ah, there we go. Ooh. Okay, that's worrying. What do we do? Proc return do scope expression only. Okay, I really don't like the error message that we got, but it looks like that's what the issue was. There should have been a do. There's no such thing as expression only, because we have to have do. So it's like, yeah, this part we got rid of actually. I didn't like the error message. Proc return do scope. This is a do scope. I guess we can see with these which ones changed. That's what we added. And then the rest were up here. Let's try rerunning that. Okay, it's going for a while. All right, it's code 0. So I think we were successful in adding do, which I'm actually really liking, this do. And now we have anonymous procedures. I can just say, hey, here's a procedure, it has no name, but I want to assign it to this value. Cool. Happy. All right. Thanks for stopping by. Have a good one. Ciao for now.